Hello and welcome to helpyourmath.com. In this video, we're going to take a look at complex fractions because I know what you were thinking. The one thing that's missing from fractions is more complexity. First, let's start with the definition of a complex fraction. A complex fraction is a fraction that contains a fraction in the numerator, denominator, or in both places. Some examples of complex fractions include 2 over 3 over 4 over 9. So we see that there's a fraction in both the numerator and the denominator for that one. We could also have x plus 4 over x plus 1 divided by 7 would be another example of a complex fraction. We know that this is a complex fraction because the denominator has a fraction within it. How do we know where that complex fraction is? So how do I know that that's really in the denominator, the x plus 1 over 7, and that the numerator isn't x plus 4 over x plus 1? Well, one way we usually can identify is because the fraction bar of the overall fraction is longer than any fraction bar within the numerator or denominator. So you can see under the x plus 4, the fraction bar is much longer than under the x plus 1. So that's kind of one indication to us. Okay, so what else do we have? How about if we have 2x over y plus 3, all divided by 12. So we see this time, where's the complex part of this? In the numerator. The 2x over y plus 3 is the numerator, and then we have just that non-complex 12 in the denominator. One more example that's going to be even more, it's like a complex fraction. We could see something like 1 over x plus 2 minus 1 over x divided by 1 over x squared minus 4 minus 1 over x squared. So these can get really, really complicated as opposed to just mildly complicated. So how do we deal with these beasts? Here are some suggested steps. 1, if needed, rewrite the numerator and or the denominator as one single term. The first few examples we look at, we're not going to need to do this, but the very last example in this video, we will have to rewrite. So what does it mean to be a single term? If we have something like 1 over x plus 1 over 2 over whatever, this is not one single term. This is two terms. This is one term, and this is one term. So two terms, we would need to rewrite it as one term. How do we do that? The same way you would add two rational expressions in general. You would need to find a common denominator, then add the numerators across the top. Okay, rewrite the big fraction using the division sign. So the division sign I'm talking about here is this one here. So I can start now with, let's say we have that 2/3 over 4/9. The first thing I would want to do, I don't have to worry about the first suggestion because this is one single term, this is one single term. But I'm going to rewrite using the division. So I'm going to say 2/3 divided by 4/9. Okay, after this, rewrite the division of fractions as multiplication by multiplying by the reciprocal of the divisor. We want to multiply by the reciprocal of the divisor. This is the divisor, the one that's doing the dividing. So we're going to rewrite this as 2/3 times the reciprocal of 4/9 is 9/4. Now that it's written as multiplication, and only now, we want to factor the numerator or denominator if anything is factorable. We're not talking about rational expressions here. These are just numbers, so we don't have to worry about factoring. But any example where we do see variables, check to see if anything's factorable. Now let's simplify before we multiply. So for example, 2 and 4 are both divisible by 2. 2 goes into itself once, it goes into 4 twice. 3 and 9 are both divisible by 3. 3 goes into itself once and it goes into 9 3 times. Multiply straight across and we get 3 over 2 as our simplified answer of 2/3 divided by 4/9. Okay, let's try it again. We want to simplify as much as possible. So step 1, figure out where that big fraction bar is. It's going to be right here, and we're going to rewrite it using the division sign. So we're going to say x over 6 divided by x over 8. Now from here, we can take the division of fractions and rewrite it as multiplication by multiplying by the reciprocal. So this would give me x over 6 times the reciprocal of x over 8 is 8 over x. Now we're ready to see if we can simplify before we multiply. So let's see, I see common factors of x here. So x goes into itself once, it goes into itself once. And 6 and 8, they have a common factor of 2. 2 goes into 6 3 times, 2 goes into 8 4 times. And now we're ready to multiply straight across. 1 times 4 is 4 over 3 times 1 is 3. So this whole thing, x over 6 divided by x over 8, ends up being equivalent to 4 over 3. Okay, we're gonna take these up a notch now. We're gonna keep compounding these and get a little bit more complicated as we go. What's the first thing we wanna do here? We wanna rewrite this using the little division sign. So I'm gonna put the numerator, 2x plus 4, divided by 5, divided by, using this guy, x plus 2 over 15. I would suggest just starting with this step and then multiplying that by the reciprocal. You don't want to do too many steps at once because you might end up confusing yourself. Just take your time with these, one step at a time. Now that we have the division sign, we're ready to rewrite as multiplication by multiplying by the reciprocal of the divisor. That doesn't do anything to our first fraction. We have 2x plus 4 divided by 5. We're going to rewrite this as times 15 over x plus 2. Now, I want to simplify before I multiply. However, we can factor one piece. There's one numerator that can be factored, so I want to make sure that I factor that first. This is, if you want to rewrite the whole thing, you can. If you just want to rewrite the factored right above it, that's probably fine too. Just to save space, I'll just put it right above. So 2x plus 4, those two terms have a GCF of 2. So I know that this is equivalent to 2 times x plus 2, right? If I factor the 2 out from both terms, I have 2 times x plus 2. Now I'm ready to look for common factors. Hey, that x plus 2, there's one of those factors in the denominator as well, so I can simplify the x plus 2 factors, those become 1s, and the 5 and the 15 are both divisible by 5. 5 goes into itself once, it goes into 15 3 times. The denominator has turned to 1, so I know I can stop checking. I can't simplify any further. And dividing by 1 just means there's no denominator left, right? Dividing by 1 is not going to do anything, so I'm just going to write whatever is in the numerator. We have 2 times 1 times 3, which is 6. So that whole messy complex fraction is equivalent to 6, or 6 over 1, but 6 over 1 is 6. How about this example? Getting even more complicated. Okay, so first I'm going to write it as division. That's going to be x minus 2 divided by x squared plus 6x plus 9. Then we're going to do our division sign. Let's just rewrite that denominator, x squared minus 4 divided by x plus 3. It's still not written as multiplication, so I don't want to check for factors yet, common factors between the numerator and denominator. Now that I've rewritten it using the little division sign, now let's apply that property that says this is equivalent to multiplying by the reciprocal. I'll get x minus 2 divided by x squared plus 6x plus 9 times the reciprocal will be x plus 3 over x squared minus 4. Okay, the next thing that I want to check for is I want to see if I can factor any numerator or any denominator. X minus 2, can't factor that. X squared plus 6x plus 9, yes. That is a perfect square trinomial. If you didn't recognize that, that's okay, because it's not too bad to do target product, target sum. This is going to factor into, I'm just going to cross that out as I rewrite, it's equivalent to x plus 3 quantity squared. X plus 3 can't be factored. X squared minus 4, that's a difference of squares, so that's going to factor into x minus 2 times x plus 2. Now that I have everything factored, now I'm ready to look for common factors. Oh look, here's a factor of x minus 2 in the numerator. I see one there, I see one down here. And I have 2 factors of x plus 3 in the denominator, but only 1 in the numerator. So I'm going to get rid of, or I'm going to simplify away one of them, which is going to get rid of that exponent, right? That's going to leave me with just 1. Now the numerator has turned to 1s. Does that mean we can just get rid of the numerator? No, we have to keep the 1 in the numerator. This is different than when we have a 1 in the denominator. We're going to have 1 over, what do we have left? X plus 3 times x plus 2. I'm happy to leave my answer like this. You should talk to your instructor to see if they want you to multiply the x plus 3 times x plus 2 in the denominator. If you don't have to, I strongly suggest you don't. I would just leave it like this, move on to the next problem. How are we doing so far? So far, so good? Okay, we have one more example. Here we go. We're going to simplify as much as possible. Wait a minute. Okay, we have a problem with this one. This one's different than all the rest. Why is this one different? Because in all of the previous examples, we've had one single term in the numerator and one single term in the denominator. So everything we've seen up until this question, we've been able to just go ahead and immediately rewrite as division with the little division sign. We don't want to do that yet here. We want to rewrite the numerator so that it's just one term. So let's look at just the numerator for this one. The numerator we have 3 minus 1 over b minus 2 over b squared. This is 3 separate terms. We want one term. How do we combine these? Well, this is subtraction of fractions. How do we subtract fractions? We find a common denominator. So what's the common denominator here? Well, the first 3 has a denominator of 1, and then we have b and then b squared. So the least common denominator is going to be b squared. I can quickly rewrite each of these 3 terms to have a b squared in the denominator. What do I need to multiply 1 by to have a b squared? I need, well, b squared. So I'm going to multiply by b squared. And whatever I do to the denominator, I do to the numerator. So that way we're really just multiplying by 1. In the middle, I have 1 factor of b. I need 2, so I need to multiply by a second b. So I'm going to multiply by b. Whatever I do to the denominator, I do to the numerator as well. And the third term already has the b squared denominator. So now they all have a b squared denominator. We're going to rewrite this as 3b squared minus b minus 2, all divided by b squared. So first step, if we need to, is you need to rewrite the numerator to be just one single term, rewrite the denominator to be just one single term. So this is, our new numerator is 3b squared minus b minus 2 divided by b squared. Okay, how about that denominator? The denominator, we also have some issues. So in the denominator, we have 1, which I'm going to write as 1 over 1, minus 1 over b squared. Our least common denominator for the denominator is also b squared. The 1 is missing everything, so it needs to be multiplied by b squared over b squared. Now we can rewrite this. It's going to be b squared minus 1 over b squared. Gorgeous. Okay, so now we have b squared minus 1 over b squared. Okay, that was step 1. Now we're ready to rewrite this with the little division sign. I strongly suggest you don't do that until you've rewritten both the numerator and denominator as single terms. And the reason for that is because if we had something like 1 plus 1/4, you can't take the reciprocal of that as separate numbers. You can't say, well, the reciprocal of 1 is 1 and the reciprocal of 1/4 is 4. So the reciprocal of 1 and 1/4 is 5 apparently. No, that's not how we take reciprocals. You would need to rewrite this as an improper fraction, and then you'd be able to take the reciprocal. So we don't take the reciprocal of separate terms. We need just one single term to be able to take the reciprocal. All right, so now we have 3b squared minus b minus 2 divided by b squared divided by b squared minus 1 over b squared. Now we're ready to write this as multiplication. Just due to lack of space, I think we also want to start thinking about the fact that I need to factor here. 3b squared minus b minus 2, that's going to be a complex factoring because we need to do target product, target sum, and we need to expand the middle. So just while I'm about to run out of space here, I'm going to go up here and I'm going to factor the 3b squared minus b minus 2. The target product will be 3 times negative 2, negative 6, and the target sum is negative 1. So we're looking for two numbers that multiply to negative 6 and add up to negative 1. I think our winning combination is going to be minus 3 and plus 2. So I'm going to expand. I'm going to rewrite this minus b as minus 3b plus 2b, right? Because it still adds back up to minus b. So that gives me 3b squared minus 3b plus 2b minus 2. Now I can factor by grouping. So I have 4 terms. I'm ready. The GCF of 3b squared minus 3b is 3b, leaving behind a factor of b minus 1. 2b minus 2 has a GCF of 2, leaving behind b minus 1. So this will factor into b minus 1 times 3b plus 2. Okay, so just when I go to do this reciprocal, I'm just going to write that instead due to the lack of space that I have since I took up so much room over here. We have b minus 1 times 3b minus plus 2 divided by b squared times b squared over, and then b squared minus 1, that's a difference of squares. So we can rewrite it as root minus root times root plus root. And now we're ready to look for the common factors. It's written as multiplication, everything's one term, we're good to go. Or yeah, one term. Okay, so we have, oh look, the b squareds will cancel, fabulous. And we have a factor of b minus 1 in both the numerator and denominator. leaving behind our final quotient of 3b plus 2 divided by b plus 1. That was a lot of work, but we got to the end. So remember what we had to do first? Write it as a single term in the numerator and a single term in the denominator. We have to do that by using the rules for adding and subtracting rational expressions. Once we did that, then we could rewrite it using the little division sign. Then we're able to take the reciprocal, factor, look for common factors, and then multiply whatever remains. Now, there was a shortcut I could have taken to make my life a little bit easier and would have really helped, but I didn't do it. I wanted to go through it like this first. But one thing, when we get right here, do you see something? Do you see how the denominators match? If the denominators match completely, they're the exact same factor, you can actually divide them there, and then just the numerator of the numerator will become the numerator over the numerator of the denominator, right? So if I had gotten, like right here, you can see we would have this would be our numerator, which is this here. This would be the denominator, which would be this here. So you can just, if they have the same denominator, you can just get rid of them and squash the numerators into just that one single fraction. So that's a shortcut. If it helps, use it. If it doesn't, don't do it. But these have been examples of looking at complex numbers and rewriting them so they're not complex. Thank you for stopping by.